common configurations, these are images that are taken from this, this paper that just came out by Scarano. Shows some typical configurations. One, the first of which called a cross configuration. And this is this picture, or this cartoon. Imagine looking straight on towards the cameras. So the cameras themselves form a cross pattern. And the orientation of this cross pattern doesn't really matter. This one has the advantage that the Scheinflug angle is relatively simple. Looking down on the setup, you can see how the cameras are arranged. Looking at the flow field, in this case, it's in more or less a side scatter setup. You can also arrange your cameras linearly, and I apologize that our beam is a little bit dim here. Like we have over in the setup at the front of the room, we have the cameras arranged in a linear fashion. Sometimes this is dictated by your optical axis or just ease of setting the system up. Both have been used extensively. If you have all things being created equal, there is an advantage to the cross setup simply because we're trying to reconstruct a three-dimensional volume, and if you have more different viewing angles, three-dimensional angles of each camera, you have more information that's better reconstruct that volume. Also to consider, just like for stereo PIV, you need a minimum angle between your sensors. If the sensors are too close together, you don't have as much information in the outer plane component of the particle field. So this angle B, known as the optical aperture, should be at least 40 degrees. And this, by achieving that angle or higher, you can resolve the three-dimensional volume with higher accuracy without smearing the particles. Imagine if your cameras are too close together, then the particles will become elongated when you do the reconstruction. Okay, so that's something to pay attention to when you're setting your system up. Now, other configurations that you should consider, again pertaining to how big a volume can you look at, is paying attention to the scattered light angle. In knee scattering, the beam's down here, but in knee scattering, the forward scatter directions are much, much stronger than side scatter or back scatter. So there's more light available to your cameras. The more light that you have, the more particles you can detect in your particle field. Okay. So if you can, if possible, if you can set your system up in a forward scatter direction, so all cameras are capturing forward scatter light, you can measure in large volumes with the same laser energy density. Sometimes for convenience, you may want to set everything up in a backscatter arrangement. If you only have one window to look through, you could have the lasers and all the cameras looking through that window, and the cameras all as backscatter. So you have the flexibility to set your system up based on the limitations of your experiment, but there are certain setups that have more advantages over others in terms of the amount of light that you